This is Honors Algebra 2 Pre-Calculus, and we're doing section 9.6 in Pre-Calc, which is counting principles. So, in example 3, we have a question: how many license plates can be made with 3 letters followed by 4 digits if, in A, you cannot repeat letters and digits, and in B, you can repeat letters and digits? So, this is the fundamental counting principle. The easiest way to do this is to sort of put your blank spaces. There's your 3 letters. And there's your 4 numbers, right? And the same thing down here. Here's my 3 letters dash 4 numbers. Okay, cool. So here's the thing. When we're considering this, right, you want to think how many options are there for the first event, right? So in this case, I want 3 letters. Well, there are 26 letters in the alphabet, so I would have 26 options for the first letter. But because it says I cannot repeat digits, I would have to multiply that by the only 25 options I have for the next letter. And then there would only be 24 options for the third letter. Similarly, when I get to the digits, there are 10 digits from 0 to 9, right? So there's 10 digits, but since I already used one of them, I now only have 9 options for the next spot, and then only 8 options for the next spot, and then only 7 options for the next spot. So to figure out the total number of options, I would do these numbers. Now, nobody expects you to do this on your own. You're going to do this in a calculator. 10 times 9 times 8 times 7. All right, so we have 26 times 25 times 24 times 10 times 9 times 8 times 7, and I hit enter and get a really big number. So that's a lot of possible license plates. The answer is 7, 8, 6, 2, 4, 0, 0, 0, right? So if with no repeats, I get 78 million license plates and some change. Now, if I am allowed to repeat, then this becomes slightly simpler, but also a much larger number. So I'd have 26 choices for the first letter, but then because I'm allowed to pick the same letter again, I still have 26 choices, and then I still have 26 choices. Same thing with the digits. All of these are going to be 10 because it wouldn't matter if I had the same digit over and over again. So I'm going to get 26 times 26 times 26 times 10 times 10 times 10 times 10. So 26 times 26 times 26 times 10 times 10 times 10 times 10, right? Just like that. And I hit enter, and I get a very large number, 175760000, right? So that's 175 million possible license plates, which is kind of crazy. Interesting side note, when you look at some states and you see that they have fewer spots for their license plates, so maybe like Delaware usually only has 5 or 6 spots, and sometimes you'll see other states that have 7 or 8. Smaller states with smaller populations generally have shorter license plates because they don't need as many possibilities. But if you go to a state where there's an awful lot of people driving, like California, where there's a very high population and also a lot of people in cars, you'll see that license plates have more digits.